Hi, in this lesson we want to talk about derivatives. Now, derivatives are a branch of differential calculus, which is a branch of maths that talks about the rates of change and slopes of curves. Now, what is a derivative? A derivative is a measure of how a function's output changes concerning its input. It represents the rate at which the function is changing at a specific point and provides information about the slope of the function's graph at that point. Now you can think about the derivative as synonymous with the gradient of a function. The only difference is that the gradient of a function only works when we are working with a constant function, which is a function that has a constant gradient, where we can calculate the gradient about any point on the function and we will be able to come up with the same value. So these constant gradient functions are quite easy to compute. But what happens when we want to compute the gradient of a curve, such as a parabola? Something like this. So drawing this parabola here, what if I want to find out what the gradient is at point A? What if I want to know what the gradient is at point B? What the gradient is at point C? How do I figure all of this out? Because we know that we can figure out the average gradient between 2 points, but what if I want the gradient at that localized specific point? This is where derivatives come in, and the formula f of prime x is equals to the limit as h tends to 0 of f of x plus h minus f of x all over h. So this is the formula of first principles, and you can find the derivative of any function using this formula, but it is hardly the case that you ever need to use this formula, because this formula is just a method to arrive at the answer, whereas there's a much simpler way that you can arrive at the same answer without doing these or following these tedious steps. So when we want to find our localized gradient, almost like the instantaneous gradient, we basically do the same thing we do when trying to figure out the actual gradient, finding the gradient between 2 points, but then we bring the difference between those 2 points so close together that it eventually overlaps on itself, and the difference between them is just so small that it is negligible, and there's a difference of h in that case. So this again won't be useful when trying to apply this formula to find the gradient, because should we be given something as complicated as f of x to the power of x cubed minus 4 all over x to the power of minus 1, something like this will be quite difficult to work with using this method, but we can follow the shortcut method in order to find the gradient of any function as well, so long as we put it in its most basic format. So what we're gonna do here is we're gonna change it such that x is no longer in the denominator, and it's gonna look like this. So it will be x multiplied by x to the power of 3 minus 4. The reason our x became to the power of positive 1 is because by moving it up here we changed the sign of the power, which is what has happened, giving us x to the power of 4 minus 4x. Now using this function we can apply the law of derivatives. Firstly, we multiply by the power. So multiplying by the power gives us 4x. Then we subtract 1 from the power, leaving us with 3. Similar thing we do here. 1 times minus 4 gives us minus 4. And then 1 minus 1 is 0. x to the power of 0 will just be 1, and 1 times minus 4, well, that will just stay minus 4. So whenever we have minus 4x, we just write it as a constant. Should we have had something like plus 3, then it doesn't matter. We won't be writing that over here. So if there's a constant, it just falls away. And then we're left with the first derivative of this function of f. So always, if you're given something complicated in terms of x, such as x squared minus 3x plus 1 all over square root x, move the square root x outside, out of the denominator, even if you have to make the power negative. So this would become x to the power of minus a half multiplied by x squared minus 3x plus or x squared, yeah, minus 3x plus 1. Then you multiply in by that, and then you find the derivative. So it is that simple. You just need to follow these steps and you'll be fine.